Hello friends, here again I'm come with another problem of finding derivative using the power rule. I hope this will also give you a little bit more concept in using power rule to find the derivative. And since the question is saying we have to use the power rule, so let's first talk about the power rule. Suppose if you have a function y equals to something base, you can choose like suppose z to the power n. Try to understand. Z is your function whose power is n, and if you have to find out the derivative of this z to the power n, and with respect to x, then derivative of the function y with respect to x is actually derivative of z to the power n with respect to x is equal with derivative of z to the power n with respect to z, because you have to differentiate with respect to z only, times, and after that you can find out the derivative of z with respect to x. And now here actually z to the power n it is, then what you will write, it will be n times z to the power n minus 1 times dz, or derivative of z with respect to x. Or sometime I might have given you something like this, like if you have a function like y equals to x to the power n, then I might have said dy over the dx, or you can say derivative of x to the power n with respect to x is equal with like derivative of x to the power n directly, in the place of here, since both are same, so you can say like derivative of x to the power n with respect to x times derivative of x with respect to x. Here x is representing actually base. Here doesn't mean like this x and this x may be same here, but it's just a coincidence this both x are same. It's just a coincidence, right? But here x is representing actually any base. It can be anything. Like here, if you see, here's the x is representing here this z, right? And if you see the same x here, x is representing this 2x plus 3. So this x can be anything, right? This is base. So whatever you have right here, so in next step you have to differentiate with respect to the same quantity, right? Here I had the base z to the power n, so in next step I differentiated this with respect to z. Later you will be learning trigonometric formula, so there at that time if you have like sine squared theta, then again that time also you have to differentiate with respect to sine theta. So d sine squared theta divided by d sine theta you have to do, right? I mean to say whatever the base you have to differentiate with that base only. So x to the power n is here, right? X to the power n is here, so that is why x to the power n divided by dx. X, I'm now assuming this x and this x is same. Here it may be same, may not be same, right? And next time dx over dx. So since it was a constant, so we can cancel out now, and dx to the power n, we know that is n times x to the power n minus 1, right? Finally what we get this one. So similarly actually we need to find out here, our given function is actually y equals to 2x plus 3 whole to the power 2. Okay, so now my derivative of this function, I'm differentiating with respect to x now in this case. Okay, so now it will be d 2x plus 3 whole square divided by dx is actually, now see here, look at this now, see, x to the power n it is, and with respect to x, so here x is representing a base, like any kind of base it may be. Just for this instant you can say this 2x plus 3 is a base, right, which we are going to differentiate with respect to x. Then it is actually derivative of 2x plus 3 this base square with respect to this only, with respect to this 2x plus 3 only, with respect to 2x plus 3 only. You can differentiate with that only, right? But after that you can find out the derivative of this thing, of this base only, right? Next time we'll be finding out the derivative of the base. So that is, our base is 2x plus 3 and then whole divided by dx. Now see, first differentiate the function with respect to the base, and then finally find out the derivative of the base with respect to x, with what you're going to find out, right? First what you have to do, you have to differentiate the derivative of the function, right? Whatever the function you have, differentiate with respect to the base what you have, right? Function over the base, and next time you need to differentiate base with respect to what you're going to, what your question is saying, or about what you're going to differentiate. about what you're going to differentiate about. Or you can simply say with respect to x. Here in this case you are differentiating by the x, so you can differentiate with the x, right? It is just a thing to make you understood. First find like first differentiate the function with respect to the base, like the function's base. What is the function's base here, right? So the function is 2x plus 3 whole square, so here you can say 2x plus 3 is your base. In this instant this 2x plus 3 is a base, so that is why you need to first differentiate with respect to base, right? Derivative of the function with respect to base, and next time again you need to differentiate this base with respect to x. Alright, this is the general way to find out. Now here I'm differentiating x, and next time I might be differentiating with the t, I might be differentiating with the m, I might be differentiating with any quantity. That doesn't matter, right? Just it's a way how to do it. First you need to differentiate function with the base, whatever we have, and then differentiate the base with respect to x, right? Depending on the situation you may not have to differentiate with the x, so that's why I will be doing a lot of problem, and that will clear you all concept. Okay, so here now what we're going to get now, derivative of 2x plus 3 to the power 2 is here. This thing actually it is saying, right? Or if you look further, they are talking about this one, right? So z to the power n is actually n. Here 2 is my n, so 2 times what is your base? This is your base. Alright, so 2x plus 3 base, right? Base to the power whatever you have, let's write that power, and subtract 1 means reduce by 1. Alright, and then find the derivative of your base. Your base is 2x plus 3, so first let's find out the derivative of this 2x only, and derivative of this 2x only will be 2, and the derivative of this 3 is a constant quantity which will be 0. So finally what we're going to get? We're going to get 2 times 2x plus 3, 2, right? 2 plus 0 is 2. So finally what do we get? We get 4 2x plus 3. So our dy over the dx is now 4 times 2x plus 3. Here we are done. This is our derivative, how to find out. I hope you understand how to use the power rule. First you should know what is your base, right? In previous videos when I was solving some few algebraic problem, there my base was only x. Every time I used to get x like something, I used to get function like 3x to the power 9 plus 4x square plus 6, something like this I used to get. So that time every time my base is actually x, right? My variable is here x, right? So I used to differentiate with respect to x, but now see something different. It is 2x plus 3 is my base whose power is 2. Alright, so keep those things. What is your base? First differentiate your function, whatever the function you have, with respect to the base, and then differentiate the base itself with respect to x, with respect to what you're going to differentiate the whole function. I hope you understand it. We'll be doing a couple of more problems related similar to this, right? So it will definitely give you the good concept. We'll be meeting in the next video. Bye bye.